Hello everyone, welcome to the new lesson, and in this particular lesson we are going to apply the square root transformation on all of our numeric variables to see whether the distribution can be transformed into more normalized way. So to do so, we at first need the code to make square root transformation. So we'll go to ChatGPT and we'll ask, give me a Python code for square root transformation. So run the command. Here you can see the code. At first ChatGPT imported the NumPy. So NumPy is a library that is must require to make any mathematical or advanced mathematical calculation with your Python code in Jupyter Notebook. So you can see ChatGPT imported NumPy as a short from NP. So whenever we will call NP in our code, that means we are referring to the any functions that derived from the NumPy library. So at first you have to ensure that you have installed the NumPy library by using pip install NumPy, and then you imported the NumPy package. Okay. After that, you can see a sample numeric variable is created and loaded within the data variable. We have our numeric variable. So we just need this particular line of code. You can see that np.sqrt. So sqrt is a function that is used for square root transformation, and this function is derived from the NumPy library. That is why np.sqrt is written, and within the function you can see the numeric variable data is transformed. So we just need to copy the code, go to Jupyter Notebook and paste it here. So we have to make some changes. So at first we are transforming our order value. So you can say transform underscore order value, and we can make it sqrt underscore order value to refer this particular variable is store the square root transformation of order value variable, and then we have to bring in the values of the variable order underscore value underscore euro. So we have done this as well, and now we can run the code. So you can see the code runs perfectly. However, let's check the distribution at first to see whether the distribution of order value becomes normal. To do so, we'll plot the KD plot, and we'll just copy the codes of KD plot, sns.kd plot function, and then we'll just replace the values of our real variable order value euro by the values of sqrt underscore order value that includes the square root transformed values of our actual variable. Just run the code. So here you can see the distribution. If I refer to this graph, you can see here there was a very long right skewness, but the right skewness is reduced at a most way. So we can say that the square root transformation for order value euro converted it to near normally distribution or normally distributed. Then we will use the square root transformation for another variable, which is cost, to see whether this transformation is able to transform the right skewness to normally distribution. So here we'll write cost, and as you can see that we have copied and pasted the function or the code, and we have replaced the order value euro by the variable cost. Now we can copy and paste this small line of code to see the distribution of transformed cost variable. To do so, we have to copy the variable within which we will load the transformed cost variables values and replace it by the previous variables values. And now we need to run the code. So here you can see that the distribution of cost is also converted to near or approximately normally distribution, because the right skewness is reduced as much as possible by using the sqrt function from the NumPy library, and we have done this for our variable cost. Now we are going to do the same thing for our refund variable. we have copied and pasted the codes and we need to make some revisions. At first, this particular variable will be called for the square root transformation for refund data, and we have to change the variable name to refund because we are using the refund variable values for the transformation. And for the KD plot, we have to replace the transformed cost with the transformed refund variable values. Now we have to run the code. Oh no, you can see that transformation becomes worst for the variable refund. So the square root transformation does not work properly for the variable refund. If I compare it with this particular distribution, you can see that green one indicating the distribution of refund, it was more normal compared to this particular transformation. However, we are going to use other transformation like logarithmic, box and Eugenson step by step. So in the next lesson, we are going to use the logarithmic transformation in our three variables to see which particular transformation provides us the accurate normal distribution for our numeric variables. That's all for square root transformation method. Thank you.